I was talking to someone I know about ghosts and spirits. Actually, it was more like I was listening to them ramble on and on about all sorts of crazy supernatural anecdotes. Seeing that I wasn't contributing much to the conversation, that person got a bit suspicious and asked, "You don't believe in ghosts or spirits, do you?" I had no choice but to come clean, so I let them know that no, I do not believe in those things. Sadly, I could see that my response rubbed him the wrong way. He was exuding some strange mix of anger and disappointment. In his frustration, he kind of blurted out, "So, you think there are no spirits or ghosts then?" I had to take that opportunity to clarify to him that I never claimed that. What I said was that I do not believe in those things, meaning, so far, I see no reason to believe in those things, which is not the same thing as me having reasons to think that souls or ghosts are not real. He ignored my clarification and went on a loop of accusing me of having beliefs I don't have, no matter how many times I clarified my views. But what was causing this confusion? In the next few minutes, we'll answer that question while introducing one of the finest tools of science and philosophy. Let's dive in. It was in the middle of that conversation that it occurred to me that the person I was talking to definitely didn't witness one of the simplest but most powerful tools of any good thinker. That tool is the null hypothesis, or put in everyday terms, it is the power of admitting to yourself that you don't know when you don't know. When I was telling the person about not being convinced of ghosts and all, I meant that in a sense that's very foreign to that person. The person I was talking to was more familiar with a wholly different form of thinking. In his world, things are super polarized, meaning that if you don't believe in something, he will assume you believe in the opposite of that thing. But the null hypothesis that I just mentioned teaches us a superior form of thinking, and here's how it works. Let's consider the claim made by Jimmy that his lucky charm protects him from harm. What the null hypothesis teaches us is to not instantly rush to acceptance of this claim, or even its opposite. We don't have to believe it either way. We are to withhold beliefs about it until we have collected sufficient good evidence supporting our conclusion, which means we can arrange a fun experiment to test it. For example, we could put Jimmy in a high-stakes do-or-die scenario while wearing his lucky charm. But we don't want YouTube to kill my channel over a shitty joke, so let's pick another example. Say Jimmy instead claimed that when you throw something, how far it goes before it touches the ground depends on how big it is, assuming of course that factors like weight, launch speed and angle are kept the same. Now, I would like you to pay attention to how your brain responds to this claim. If you are normal, your brain is probably already working out if Jimmy's claim is right or wrong. But if you are not normal, and your dad dropped you on your head when you were little, then you think like me. That is to say that you look at the claim and assume the null hypothesis. Put simply, you assume that the size of an object has no effect on the distance it can travel until good evidence shows otherwise. But how do we test it then? Let's consider the simple simulation to do just that. What you're looking at is a simulation of a cannon that is set up to launch projectiles out of it. In this case, I set it up to launch at an angle of 45 degrees and at an initial velocity of 15 meters per second. Let's just look at the launch of the first cannonball, which is our largest cannonball with a 1 meter diameter. As expected, it flies some distance and lands on the ground. So let's fire our second cannonball, but make it just a little bit smaller. As you can see, it seems to have started off with a very similar trajectory, but ended up traveling a little bit further than the first ball. But maybe something else disturbed it somehow and we are being fooled. How can we be sure? Well, we can do more trials with smaller sizes. Why not? As you can see in the simulation, it is starting to look like we can indeed control how far the object travels by changing its size. But this evidence does not fit our null hypothesis, which, if you remember, did not accept that size mattered. We therefore have to reject our null hypothesis and conclude that the most reasonable position is to support Jimmy. He was right. See, that wasn't complicated at all. We did not have to start with a bias for or against Jimmy. The meaning or point of our null hypothesis wasn't to claim or prove that size doesn't matter. It was just our neutral starting position. It helped us avoid forming beliefs about Jimmy's claims before we actually verified and validated it. That is a good demonstration of how a scientist or a philosopher applies the "I don't know, let's figure it out" method. This method isn't only intellectually sound, but also the most moral one. Mind you, I'm not saying that you must do all the hard work of proving all your supernatural beliefs. I just want you to be lucid and aware that those beliefs are untested, and maybe "I don't know" is a more worthwhile and honest position to take on those matters. And remember that pretending to know the answer when you don't doesn't only make you wrong, it keeps you away from discovering the correct answer as well. Now that you understand the null hypothesis, hopefully you already understand why me stating my lack of belief in ghosts and spirits in that earlier conversation wasn't a claim about them not existing. This has been the Scientalist. See you in the next video.